lettuce is still king on the Central Coast. The quality can't be matched, and almost year-round supplies provide a reliable product flow to markets nationwide. New varieties of both iceberg and romaine continue to enhance qualities associated with lettuce. Consistent arrivals with flavor and texture consumers ask for. Of course, consistent yield and quality don't come easy. It takes fertile soils and close attention to irrigation and crop inputs, and planting varieties matched to local growing conditions.
Then it's up to those managing the crop to make sure that each lettuce planting receives optimal amounts of water, nutrients, and protection against pests. Is there a right way to grow lettuce to achieve these consistent, bountiful harvests? Top agronomists in both private industry and universities are saying yes, especially when it comes to managing the very important nutrient nitrogen. Of course, proper plant nutrition is complex and involves more than just nitrogen fertilization.
Essential nutrients such as calcium are also applied in high-yield lettuce fields in conjunction with other nutrients such as phosphorus and potassium. And it goes without saying, proper water management is essential. Lately, there's been lots of attention paid to nitrogen and nitrate, the form that can leach into groundwater. Many groundwater basins on the Central Coast and Central Valley are contaminated with nitrate at levels exceeding safe drinking water standards. The State Water Resources Control Board has responded by adopting the nitrate control program, which is impacting every industry in California where nitrogen is used as an input or where waste discharge contain nitrate. Testing of groundwater aquifers in the Central Coast is finding that much of the nitrate contamination is attributable to applications of synthetic nitrogen fertilizers, compost, and animal manures applied to irrigated cropland. Other nitrate sources, such as wastewater treatment plants for cities and rural septic systems, also contribute to nitrate contamination of groundwater in localized areas.
Agronomists and researchers have devised a management approach for optimizing applications of nitrogen to crops to minimize leaching of excess nitrate while optimizing crop production. The approach is called the 4 R's: the right rate, right time, right place, and right source. For lettuce, the University of California, with support of the California Department of Food and Agriculture, has spent years refining the 4 R's and now has many proven practices ready to be used today in California lettuce. Before going into the details on the 4 R's, it's important to understand the relationship between soils, nitrogen, fertilization, and irrigation practices. In particular, how nitrate moves in the soil and how it is taken up by a lettuce plant, essentially how all the science turns into management implications and tools. A fundamental point to remember: any source of nitrogen applied as a nutrient can convert to nitrate. If conditions are right, nitrate can eventually leach beyond the root zone and into groundwater aquifers.
Other factors are in play with nitrogen, such as soil mineralization, losses to the atmosphere, and biological processes. But leaching excess nitrate to groundwater is a major focus these days and deserves much attention. Nitrate leaching into groundwater is primarily a result of excess fertilizer nitrogen applied that is not taken up by the plant during the growing season.
In order to predict when and how much nitrogen a plant will take up, we first have to understand why nitrogen is important for plants. Lettuce plants use more nitrogen than any other nutrient. Nitrogen is used in the plant's DNA, in hormones that signal the plant to perform certain functions such as cell division. Nitrogen is also a component of amino acids, which are used by the plant to make enzymes that are important for cell functions. Nitrogen is also critical for chloroplasts, which are the plant's sugar-making factories. When nitrogen is deficient in the plant, it can limit growth and cause leaf chlorosis. For all these reasons, we want to ensure an adequate amount of nitrogen is available for the plant throughout its growth cycle, but we don't want to apply extra nitrogen.
When thinking about nitrogen applications, you want to provide just enough to meet crop uptake demand. You also need to consider all the sources of nitrogen. Nitrogen provided by commercial fertilizers, nitrate in irrigation water, mineral forms of nitrogen in the soil, as well as various types of organic matter. Organic matter comes in many forms: crop residue from previous plantings, composted manure, green waste, incorporated cover crop residue, and soil organic matter.
Before planting, it's important to take a soil test to measure the amount of nitrogen available to the crop at planting. The soil nitrate test measures the plant available nitrogen at the time of sampling, accounting for previous crop residues and applied nutrients.
Of course, soil tests for nitrogen are very field and time specific. Ideally, you would take a soil sample that's representative of the field every time before you're about to fertilize. First, keep in mind that lettuce doesn't need a lot of nitrogen for the first 30 days. So unless you have good evidence that it's going to be deficient in the soil, which you can figure out by testing your soil, you probably can avoid it. Also, if you're putting anti-crustants on the soil at planting that contain nitrogen, that is nitrogen that you should also account for. If you're going to thin the lettuce with a product that contains nitrogen later on, that is fertilizer that you can credit for your crop. Also, you might want to think about what the previous crop is. If you are on your second rotation in the season or third rotation, it's likely you've incorporated a lot of residue that's going to mineralize nitrogen. And so you rarely need to do any pre-plant nitrogen fertilizer on your second or third rotation. The pre-plant application rate depends on residual soil nitrate nitrogen and is rarely needed unless soil nitrogen is less than 5 parts per million. If the residual soil nitrate nitrogen concentration is lower than 5 parts per million, a small application just before or at planting is sufficient to cover the early plant needs. Apply only enough nitrogen to increase the soil available nitrate to 10 parts per million nitrate N. For reference, it takes about 4 pounds of nitrogen per acre to increase the soil nitrate level by 1 part per million nitrate N. If the residual nitrate nitrogen concentration is above 10 to 15 parts per million, no pre-plant nitrogen application is needed. Fertilizing, if soil levels are above 10 parts per million, will more likely be leached during irrigation events for germination or establishing transplants. Keep in mind that too much nitrogen can cause salt burn and increase the risk of nitrate leaching.
To help understand how to effectively manage nitrogen applications, it's important to understand the different forms of nitrogen in the soil and how nitrogen is taken up by lettuce plants. There are basically 2 main forms of nitrogen in the soil: organic and mineral. Soil organic matter consists of incorporated crop residues, compost, and other organic amendments. Mineral nitrogen consists mainly of ammonium and nitrate forms of nitrogen that are directly taken up by the plant. Soil organic matter is the nutrient storage bank in your soil and comprises on average 0.5 to 2% in Central Coast soils. In the short term, organic matter nitrogen is tied up in big, complex organic molecules that are not immediately available to plants. But over time, this organic matter breaks down and provides a steady supply of ammonium and nitrate to the soil and roots.
Ammonium and nitrate are the mineral forms of nitrogen that is directly available for plant uptake. Being positively charged, ammonium can stick to soil particles, which are predominantly negatively charged and hence does not leach easily. Nitrate is the other form of mineral nitrogen that roots can take up from the soil. However, nitrate is negatively charged, so it cannot stick to the soil particles, making it susceptible to leaching. As a reminder, when we talk about the cation exchange capacity in soils, we mean the ability of a soil to temporarily hold on to positively charged molecules. Ammonium is one of those positively charged molecules typically found in soils. How do these forms of nitrogen cycle into different forms in the soil?
Let's start with soil organic matter, such as previous crop residues, applied compost, or incorporated cover crops. As organic matter is broken down by soil microbes, it slowly releases ammonium In warm, moist soils, this can occur in a matter of weeks to months, while in cool soils, below 55 degrees Fahrenheit, this can be a very slow process. The carbon to nitrogen ratio in the material is critical. The higher the ratio, the slower the breakdown and the slower the mineralization. Because this process is driven by microbial activity in the soil, it's very complex. As with all biological processes, it happens faster when moisture is present, when there's oxygen for microbes to use, and when temperatures are warmer, and when organic matter has a lower carbon to nitrogen ratio. When you apply organic amendments such as compost, you stimulate microbial activity, and those microbes require nitrogen and carbohydrates, both of which are present in compost.
A good rule of thumb is that if the compost is less than 2% nitrogen, any nitrogen is going to be tied up by those microbes for a period of time until those microbes die. So, in organic systems, or if compost is applied as a supplement to conventional fertilizer, it's important to understand the nitrogen content of the compost, since its availability to the plant can be delayed until the compost breaks down. Once nitrogen is in the ammonium form, it can turn into nitrate through a process called nitrification. Nitrification is also microbe-driven, so the rate at which this occurs depends primarily on temperature. In California soils, nitrification happens in a matter of days to weeks throughout the growing season. As a consequence of this rapid microbial action, the nitrogen in soil organic matter converts to ammonium, which turns into nitrate and is leachable if it's not taken up by the plant.
This especially applies to the fertilizer urea. It quickly converts to ammonium, then nitrate, which can leach if it's not taken up by the plant. So how fast does nitrogen in organic matter and ammonium nitrogen turn into nitrate? At 50 degrees Fahrenheit, it takes 4 weeks for 40% of ammonium present to convert into nitrate. At 60 degrees, in the top 2 to 3 inches of soil, 60% of ammonium that you apply will turn into nitrate in 2 weeks if it's not taken up by the plants. At 75 degrees, it only takes 2 weeks for 100% of the ammonium to turn into nitrate.
Now let's talk about how nitrogen moves in plants. Nitrogen uptake in lettuce is closely related to the plant's growth stages. Early in the season, nitrogen needs and uptake is low. Because lettuce plants take up less than 20% of the required nitrogen during the first month after planting, the need for a pre-plant nitrogen application is often minimal after taking into account the residual mineral nitrogen in the soil. To ensure that nitrogen is available in the root zone of young plants, irrigation should be managed carefully to limit nitrate movement below the root zone. When possible, take soil samples and analyze for nitrate before each fertilizer application, which may be several times during the crop cycle. If you apply beyond what the crop needs, the yield response is very minimal.
That is the point of diminishing returns, since most of the nitrogen applied will leach down instead of being taken up by the plant. Matching the crop demand and growth pattern is the rule of thumb for yield assurance and return on investments. Translated to a management practice, that means that monitoring the soil nitrate levels and applying smaller amounts over multiple applications with more nitrogen needed toward the later growth stages of the crop. This results in less nitrogen waiting in the soil profile to be taken up by the plant, where it is vulnerable to leaching from accidental over-irrigation or poor distribution uniformity that leaches nitrate from portions of the field. The takeaway: more nitrogen applied does not necessarily mean more nitrogen taken up. And applying more nitrogen won't necessarily increase yields, especially if the soil is already at sufficient levels. Before we go on, let's talk a minute about nitrate in irrigation well water, as it is often being called pump and fertilize.
Years of research has shown that nitrate in irrigation water is available for plants to absorb and use just like any other source of nitrogen. An inexpensive well test can tell you exactly how much nitrate is in your irrigation water. Here's how to do the math. Take the test results, say 10 parts per million nitrate nitrogen, and multiply by 0.227. Each part per million represents 0.227 2.227 pounds of nitrogen per acre per inch of irrigation water applied. That equals 2.27 pounds of nitrogen per acre inch of water. If you apply a total of 12 acre inches or 1 foot of water to a lettuce crop, the total is 27.24 pounds of nitrogen per acre. Of course, not all nitrate in the irrigation water will be taken up and used by lettuce. There is one more step. Multiply 27.24 pounds times the crop nitrogen use efficiency. As a rough estimate, let's use 85% efficiency. At 10 parts per million and 85% efficiency, you should include about 23 pounds of nitrogen per acre in your overall nitrogen budget from your irrigation water.
Think of it this way. That's 23 pounds of free nitrogen applied to your crop. Better yet, you're helping clean up the groundwater aquifer. Some of the nitrogen that isn't used by the plant can cycle in the soil, but generally, any excess nitrate is susceptible to leaching into groundwater. This can occur with any type of irrigation system. If too much nitrogen is applied in a season or more than a plant can take up at a time, this can mean you're spending money you don't need to spend on something the crop won't use.
All this science about how nitrogen behaves in the soil and in plants has to be translated into practices for managing lettuce. Maybe the most important component of the 4 R's is applying the right rate of nitrogen. So a quick review of our nitrogen supply side: residual nitrogen in the soil, cover crops, manure, compost, and the nitrate in irrigation waters and synthetic nitrogen fertilizers.
Applying the right rate is about matching nitrogen supply with nitrogen plant demand. That demand includes all of the nitrogen that a lettuce plant needs to grow the roots, head, and wrapper leaves. Research on iceberg and romaine lettuce has shown that the right rate varies by lettuce type, row spacing, and plant density, among other factors. Plus, the total amount of nitrogen a crop actually needs on a per acre basis can vary widely depending on the nitrogen available in the irrigation water and already in your soil.
But there are some basic guidelines to follow when deciding on the right nitrogen rate for a particular field and planting. Where this number is most important is when completing your annual nitrogen fertilizer applications report for the Regional Water Board. In that report, you'll need a total nitrogen applied and an estimate of nitrogen removed at harvest. For the amount of nitrogen actually removed at harvest, numbers developed by recent research and commonly used nitrogen fertilizer applications are far apart. For example, in a report written by Daniel Geisler, an agronomist with the University of California, Davis, information was compiled from various studies performed over the last 10 years on iceberg lettuce grown on the Central Coast. He found that on average, 5 pounds of nitrogen was removed for every 2,000 pounds of harvested iceberg. In the same report, focusing on romaine, the results were similar: 6 pounds of nitrogen for 2,000 pounds of harvested yield. As for nitrogen crop consumption, uptake varies based on when the crop is planted, such as spring versus fall planted lettuce. As this chart illustrates, using day-degree accumulation starting after planting, nitrogen uptake begins slowly but rises dramatically up until harvest.
So if you want to try to reduce your nitrogen fertilizer during the season, before each fertilizer event, you need to evaluate how much residual nitrogen you have in your soil. And one of the fastest and most effective ways is to use the soil nitrate quick test, where you go into the field and take a composite sample from many locations to 1 foot depth and test it for nitrate nitrogen.
For a nitrogen removal rate, multiply the removal factor by the harvest weight. So, for a 20-ton per acre crop of iceberg lettuce, we multiply 2.63 pounds of nitrogen per ton times 20 tons. And we calculate that the crop removed 52.6 pounds of nitrogen per acre. For a 20-ton per acre crop of romaine lettuce, we multiply 3.62 pounds of nitrogen per ton times 20 tons. And we calculate that the crop removed 72.4 pounds of nitrogen per acre. Compare your application rates with the calculated nitrogen removed per acre based on the current research.
While we don't consider these to be official nitrogen removed numbers for the major lettuce types used for regulatory purposes, you should consider the information when building your nitrogen budget.
Now let's talk about the right time. Applying the right amount of nitrogen at the right time requires knowledge about the crop nitrogen demand, the seasonal growth and uptake pattern, and the availability of other sources of nitrogen. So applying at the right time is about matching the timing of the plant demand and root uptake. Keep in mind that a plant has biological bottlenecks called transporters that control nitrogen uptake into the roots, preventing uptake if there is no plant demand.
For lettuce, 70 to 80% of the total N required is taken up in the last 4 to 5 weeks of the crop. Because it requires energy to take up nutrients, plant uptake occurs when nutrients are needed at any particular growth stage. Lettuce plants require little nitrogen in the early growth phases. Studies have found that nitrogen uptake during the first month after planting represents no more than 20% of the total uptake. So it's not worth applying significant amounts of nitrogen fertilizer before the lettuce is 30 days old because it's not taking up nitrogen yet. If you apply that nitrogen, it could potentially leach by rain or irrigation events. Lettuce plantings from the late fall through early spring could require more nitrogen fertilizer because the available residual soil nitrate tends to be lower, especially following wet winters or during cooler months when mineralization rates are lower. If soil nitrate nitrogen concentration is below 10 parts per million, a sidrus or a fertigation through the drip system may be needed. If it's above 20 parts per million, any nitrogen applied is unlikely to be utilized by the plants. So skipping or reducing your application rate would be warranted.
When possible, in 2 weeks, check soil nitrate again to ensure levels are adequate. Check your residual soil nitrate levels after thinning at the 2 to 4 leaf stage, then again 2 to 4 weeks later at the cupping stage. Make adjustments then as needed, keeping in mind that for sprinkler and furrow irrigated fields, uniformity can be poor and there is risk of runoff leaving the field.
During the last 4 to 5 weeks of the growth cycle of lettuce, 70 to 80% of the total nitrogen is taken up by the crop. Demand is highest during this period and can reach up to 3 to 4 pounds of nitrogen per acre per day.
So, where is the right place to apply nitrogen fertilizers? Applying in the right place means knowing where the majority of roots are and applying nitrogen where roots can best take up both nutrients and water. Typically, the vast majority of important feeder roots are in the top 1 to 12 inches of soil. Roots will be more shallow in young plants, and root depth will change as the plant grows. So it's in that upper zone where you want to keep your water and nutrient applications.
At planting, nutrients are often applied in the form of an anti-crustant, which contains phosphorus and sometimes nitrogen. Remember, the amount of nitrogen applied with the anti-crustant should be subtracted out from your total nitrogen fertilizer requirement. For drip systems, fertigation is the preferred mode of application, which can readily match nitrogen applications with plant demand and place the nutrients directly in the root zone. Remember, nitrate moves with water, so if you push water below the root zone, you risk pushing nitrate below the root zone. It's important to remember that roots will be concentrated where the water is applied.
That is why fertigation is the most efficient method when using high-efficiency systems. All of the nitrogen is applied directly to an area where active roots are concentrated. And speaking of fertigation, always inject the fertilizer at the last half or quarter of an irrigation set. That way, water won't push fertilizer past the root zone. Then stop the injection 45 to 60 minutes before the set is finished to ensure the system is adequately flushed. If possible, flush the system for 2 hours after the fertigation is stopped.
The right source is about preventing the applied nitrogen from converting too quickly into nitrate and leaching beyond the root zone. As for the right source of nitrogen, there is no indication that the form or type applied will impact yield or plant growth. The most widely and effectively used fertilizer formulations for lettuce production include ammonium sulfate, calcium nitrate, urea, ammonium nitrate, and potassium nitrate. However, the short-term leaching potential can vary. Nitrate-based fertilizers are immediately at risk for leaching due to nitrate mobility, especially in sandy soils.
Early research has shown that nitrogen stabilizers used with urea and ammonium-based fertilizers may slow the formation of nitrate, leading to less potential leaching. Ammonium is a positively charged form of nitrogen and will not initially leach. However, soil microorganisms rapidly convert ammonium to nitrate. When soils are warm and moist, lettuce plants can take up both ammonium and nitrate forms of nitrogen. Again, nitrate is negatively charged and can move through the soil very easily. So keep that in mind when choosing nitrogen fertilizer and managing its application.
There is a lot that goes into selecting the right source. In particular, how much do you want to spend per acre? What application method is used, side dressing or fertigation through drip? There are many nitrogen fertilizer product options, but each has its own baggage.
Calcium nitrate is a readily available form of nitrogen, but also has a high leaching potential. This leaching potential can be managed with well-timed applications, and calcium nitrate is well suited to fertigate in drip systems. Calcium and calcium nitrate is also important plant nutrients, and having sufficient amount of calcium in the plant tissue can prevent disorders in lettuce such as tipworm. Urea ammonium nitrate, or UAN, is very popular due to its solubility in water. The urea and the ammonium in UAN makes it a little less leachable, although in warm spring and summer conditions, the conversion to nitrate is very rapid.
There are many reasons why you are making fertilizer choices, but always keep in mind the vulnerability inherent with each choice. When applying compost or manure, remember these materials need time to mineralize and convert to ammonium, making it plant available. A rule of thumb for compost is that about 40% of nitrogen is available in the first year after application, another 30% the following year, then the balance is released over several years. Depending on the type of compost, this form of organic fertilizer averages about 2 to 4% nitrogen content. So if you apply 4 tons per acre, nitrogen available the first year would be about 96 pounds per acre. And remember, availability of the nitrogen from compost is very temperature dependent. Where possible, incorporate compost soon after application.
When choosing a commercial nitrogen fertilizer, consider how much and when the nitrogen is available for plant uptake. Be mindful of the amounts of water applied in irrigations during and after fertilizer applications. Too much water can push excess nitrates past the root zone. Ask your supplier or crop advisor for the best material for your conditions and soil type.
Finally, let's summarize the right rate, time, place, and source. First, consider yield history of each field, the current year growing conditions, and the variety being planted, and use that information to develop a realistic yield potential. Also take consideration of irrigation water nitrate levels, irrigation efficiency, any amendments you're going to add, and results of a soil test. Research on iceberg and romaine lettuce has shown that the right rate varies by lettuce type, row spacing, and plant density, among other factors. So keep all these factors in mind when deciding on the right rate for a particular lettuce planting. Then we get to the right time, which means matching the timing of the plant demand and root uptake. Studies have found that nitrogen uptake during the first month after planting represented no more than 20% of total uptake. For lettuce, 70 to 80% of total nitrogen is taken up late in the season, between heading and harvest. So, additional nitrogen applications may be needed as the demand is highest later in the season and can reach up to 3 to 4 pounds of nitrogen per acre per day. Lettuce planting from late fall through early spring may require more nitrogen fertilizer because the available residual soil nitrogen tends to be lower during cooler months compared to warmer months. When it comes to applying in the right place, the vast majority of important feeder roots are in the top 1 to 12 inches of soil. Roots will be more shallow in young plants, and root depth will change as the plant grows, so keep your water and nutrient applications in the upper zone. Fertigation through drip systems is the preferred mode of application since it can place nutrients directly into the root zone. And remember, nitrate moves with water, so if you push water below the root zone, you risk pushing nitrate below the root zone. And speaking of fertigation, always inject the fertilizer at the last half or quarter of an irrigation set. Then stop the injection 45 to 60 minutes before the set is finished to ensure the system is adequately flushed. The right source is about preventing the applied nitrogen from converting too quickly into nitrate and leaching beyond the root zone. The most widely and effectively used fertilizer formulations for lettuce production include ammonium sulfate, calcium nitrate, urea, ammonium nitrate, and potassium nitrate. Nitrate-based fertilizers are immediately at risk for leaching due to nitrate mobility, especially in sandy soils. And since nitrate is negatively charged and can move through the soil very easily, keep that in mind when choosing nitrogen fertilizer and managing its application. If compost or manure are applied, these materials need time to mineralize and convert to ammonium, making it plant available. And remember, availability of nitrogen from compost is very temperature dependent. Ask your supplier or crop advisor for the best nitrogen product for your conditions and soil type. Following these simple steps will go a long way toward increasing your nitrogen use efficiency and decreasing nitrate leaching to groundwater. Best of all, it ensures you get the most value from an expensive crop input. And in this market, saving every dollar counts.